Hello YouTube. Today I'll be talking about the transformation of a sine graph, right? So let's start. So transformation, right? Transformation. Okay. So say if you have an equation like y equals 2 sine, right? Bracket 0.5 x to the positive 90, right? But close bracket negative 2, right? So this is your transformed equation, right? So I asked myself, well, what's different from the normal equation, which is just sine x, right? Well, what are the differences? Well, the first difference is the amplitude, right? Because here the amplitude is 1, right? Just 1. That's the amplitude of a normal sine graph, right? Because it goes from 0 to 1 and then goes down -1, right? So that's -1 and that's +1. In this case, we have 2, right? We have 2 as our amplitude. So that means the graph will oscillate 2 times higher than from its original one, right? Because before it was 1, now it's just gonna go 2 times more. So it's gonna go to 2, cut to the same point, and then go down 2, come back to 0, right? So it just goes up twice the more from this mean value, right? And the mean value in this case is 0, right? Because that's the middle of the graph, right? And now we try to figure out, well, we have a horizontal stretch, right? But it's in the x. So how do we take that out? Well, we factor it out, right? So let's factor it out, right? So if you have half, right, of x plus 90, if you factor half out, right, that's basically x plus 45, right? Because what you're doing is basically putting 90, right? Since its denominator is 2, so it's going to be 90 over 2, right? Because you're factoring it out, and that will leave you with a 45, and the half comes out. So then your equation should look like y equals 2 sin, right, half x plus 45 degrees, right? And your mean value, right, which is the -2, should stay -2, right? So now we have our horizontal stretch, right? So now the horizontal stretch is like one of the most important part of an equation, right? Because that's what it tells you what the period is going to be, right, of the graph. And the period of a graph tells us how long will one cycle take right? So in a normal graph is 360, right? 360 one cycle, right? But in this transform graph is not 360. So what is it then? So the equation for our period is 360 or 2 pi, right, over the horizontal stretch. In this case it's half, right? And that should give you the period, right? So what's, well, 360 over half, we'll divide by half, right? Well, that's just, well, that's 720, right? That's 720 over 1. Because you're dividing by a fraction. When you divide by a fraction, right, this will flip, right? And when this flips, then you multiply, and that should give you 720. So for the graph, where's my cursor? Okay. So for my graph, right, it should take 720 degrees, right, for it to go up for complete one cycle, right? For it to complete one cycle, and one cycle is just going one up and one one maximum, one minimum, basically, right? And returning to back to zero, right? Because sine of zero, zero is zero, right? So it should come back to zero. And now we have our horizontal displacement or phase shift, right? So if it's positive, right, we know it's gonna move to the left, right? It's gonna move to the left. And it was negative. Say if this was negative, right, then it would have moved to the right, right? So it's always the opposite sign of what they give you. So if they give you positive, you move to the negative side, negative 45, right? And if they give you negative 45, then you move to the positive side of 45, or in quadrant 1. This is quadrant 2, right? So if they give you negative, you're in quadrant 1. If they give you positive, you're in quadrant 2, right? And lastly, we have our mean value, or our vertical displacement, which is negative 2, right? So normally our graph started from here, right? Now it's going to start from negative 2, right? And that should be a new x-axis, right? Because from here, the graph will oscillate, right? It's going to go from up and down, right? From the mean value. So this is very important. So now let's graph it. Let's graph the graph. Okay. So you have this. You have this, right? Okay. Let's go by 60s. 60, negative 120, 180. What's next? 180 plus 60 is what? 240, 300, right? 360. Then it's what? 420, right? And then it's 480. Let's extend the graph a bit. Right, to there. 480. What's next? 480 plus 60 as well. 540, right? That's gonna be 600. 660. 720. Then let's give this one more. So it's gonna be 780. And then that's gonna be 840, right? Yeah, so let's just go, and they're all in degrees, right? They're all in degrees, right? They're all in degrees. What? 420, yeah, 420, 360, 300, 240, 180, 120, 60, and negative 60. They're all, my bad, excuse me, in degrees, right? And then let's just do this as, let's make this negative 2, right? And to extend the bottom graph a bit too, right? So let's just extend that a bit. So yeah, let's just make that and this 4 negative, and that's going to be 1, 2, 3, and whatnot, right? That's going to be 3, and that's going to be 1 negative, right? They're all negatives. Okay, so I will graph this in a different color. I'll start graphing in the next video, so I'll see you then.